Okay, so again, our topic for today is about quantitative data or methods or quantitative data analysis. It is one of the of those things that often strikes fear in students. No, it's totally understandable because quantitative analysis is a complex topic, no, full of daunting lingo, no, like medians, modes, correlation, and regression. Suddenly, we are all wishing we paid a little more attention in mathematics class during our statistics and mathematics in the modern world. The good news is that while quantitative data analysis is a mammoth topic, gaining a working understanding of the basic isn't that hard, even for those of us who avoid numbers and math. No? So in this discussion, our presenter was able to address the quantitative analysis down into the simple bit-sized chunks so we can approach our research with confidence. No? So again, despite being a mouthful, quantitative data analysis simply means analyzing data that is numbers-based or data that can be easily converted into numbers without losing any meaning. Let's say, for example, no, category-based variables like gender, ethnicity, or native language could all be converted into numbers without losing meaning. Let's say, for example, English could equal to 1, French is equal to 2, and others. And this contrast, no, against qualitative data analysis, where the focus is on words, phrases, and expression that can be reduced to numbers. Then quantitative analysis is generally used for three purposes. Now, firstly, it is used to measure difference between groups. Let's say, for example, the popularity of different clothing colors or brands. Let's say yellow, pink, and so on. Secondly, it's used to assess relationship between variables. Let's say, for example, the relationship between weather, temperature, and voter turnout. And third, it's used to test hypotheses in a significantly rigorous way. For example, a hypothesis about impact of the certain vaccine. Again, this contrast with qualitative analysis, which can be used to analyze people's perception and feeling about an event or situation. In other words, things that can't be reduced to numbers. So, how does quantitative analysis work? Well, since quantitative data analysis is all about analyzing numbers, it's no surprise that it involves statistics. And the statistical analysis method from the engine that powers quantitative analysis, and these methods can vary from pretty basic calculation, let's say, for example, average, no, like mode, medians, mean, no, to more sophisticated analysis. Let's say, for example, correlations and regressions. To give us more details about the topic, let us all welcome our presenters. Go ahead.
Good afternoon, everyone. We are Group 1 and we are here to tackle about introduction to quantitative methods. Here are our members: Chan Diesel, Gonzaga Jericho James, Nicolas Manuel Job, Sapiter Jacob, Shankole Jaysar, Tuasa Nairin. Next. Before we proceed to research methods, first let us know what is the definition of quantitative research. Quantitative research is a research that focuses on quantifying the collection and analysis of data. Pabalik sa slide. Quantitative research methods are a set of techniques used to gather and analyze numerical data. These methods are commonly used in the social sciences, such as psychology, sociology, economics, and political science, as well as in fields like marketing and healthcare. Research is a study that focuses on quantifying the collections and analysis of data. Typically involves the collection of data through surveys, experiments, and other forms of measurements. The data is then analyzed using statistical methods to identify patterns, relationships, and trends. Next. Here are some common types of quantitative research methods, including surveys, which involve asking a group of people a series of questions in order to collect data about their study attitudes, beliefs, or behaviors. Then experiments. This involves manipulating one or more variables in order to observe their effects on a dependent variable. Next is observational studies, which involve observing and recording the behavior of participants in a natural setting without manipulating any variables. Then we have secondary data analysis, which involves analyzing data that has been already been collected by another researcher or organization. Lastly, we have content analysis. This involves analyzing written or visual materials, such as newspaper articles or social media posts, to identify themes or patterns. Next. Here we have the pros and cons of research methods. Pros: ability to collect large amounts of data quickly and efficiently. Ability to test hypotheses and make predictions. Ability to generalize findings to larger populations. And the cons are potential for researcher bias and difficulty of capturing complex or nuanced phenomena. Next reporter.
Hello po. Naririnig ba ako? Narinig po ako.
Yes, go ahead.
Oh, good afternoon, sir. My name is Jericho James of Gonzaga, and my part is all about the importance of a quantitative methods. So the first importance is objectivity. Quantitative research methods allow researchers to gather data in a way that is free from researcher bias. The data is collected is typically numerical, which means it can be easily analyzed and interpreted using statistical tools, reducing the potential for subjective interpretation. Next is precision. Quantitative research methods provide a precise and accurate measurement of data. This precision enables researchers to make informed decisions and draw reliable conclusions. Next importance is testing hypotheses. Quantitative research methods allow researchers to test hypotheses using statistical analysis. This approach enables researchers to determine the degree of support for their hypotheses and evaluate the significance of their findings. Next is standardization. Quantitative research methods rely on standardized measurement instruments and procedures, which ensures that data collection is consistent across multiple studies. This standardization enables researchers to compare and contrast results across studies, increasing the reliability and validity of their findings. Next importance is large sample sizes. Quantitative research methods often involve large sample sizes, which can increase the statistical power of the study. This power enables researchers to detect small differences or relationships that might not be apparent in smaller studies. Next reporter po.
Hello po, rinig po.
Yes, go ahead.
Replicability. Quantitative research methods are typically highly structured and standardized, which makes it easier to replicate the study and verify the findings. Replicability is a crucial aspect of scientific research and adds to the credibility of the study. Next is generalizability. Quantitative research methods allow researchers to make generalizations about a larger population based on a sample. This makes it possible to apply the findings to other populations and contexts. making the study more widely applicable. Next is objective measurement. Objective measurement, quantitative research methods rely on objective measurement tools such as surveys, questionnaires, or behavioral observations. These tools help to minimize the influence of researchers' bias, increasing the accuracy and reliability of the data. Next reporter, please.
Decisions. Data-driven decisions, quantitative research methods provide empirical evidence to support decision-making. The use of statistical methods allow research to identify patterns and relationship in the data, which can be used to guide policy decisions and interventions. To attain greater knowledge and understanding of the social world, researchers use quantitative methods to observe situations or events that affect people. Quantitative research produce objective data that can be clearly communicated through statistics and numbers.
Statistical analysis. Statistical analysis is done on data sets, and the analysis process can create different outputs types from the input data. For example, the process can give summarized data, derive key values from the input, present input data characteristics, prove a null hypothesis. The output type and format vary with the analysis method used. It is highly used by government and management professionals in the business world. It helps professionals like analysts to understand complex scenarios and the vast data associated with them. Statistical analysis data is important in politics, generating information that fuels political theory, campaign strategy, and policy development.
Type of statistical analysis. 1. Mean. One of the simplest and most popular analysis methods, easy to apply to data. Average value of data used in research. 2 is standard deviation. Tool to determine the deviation of a set of values from the mean value. 3 is regression. Helps to comprehend the relationship between two or more variables used in the analysis. 4 is hypothesis testing. Test the validity and authenticity of a hypothesis outcome or argument. 5 is sample size determination derives a sample from the entire population representing the total population. Next, please. Role of statistical analysis in quantitative method. As a statistical data analyst role is to gather, analyze, and interpret information from relevant sources. The three activities are inherited and interrelated. Analysts must know what data will be relevant, how to analyze it effectively, and how to accurately interpret the conclusion. Thank you.
Okay, so I think the group was done now. There are two branches of quantitative analysis, no? So as I mentioned, quantitative analysis is powered by statistical analysis methods, and there are two main branches of statistical methods that are used. So descriptive statistics and inferential statistics. In research, no, you might only use descriptive statistics, or you might use a mix of both, no? Depending on what you're trying to figure out. No, in other words, depending on your research question, aims and objectives, and what are descriptive and inferential statistics? Well, before we can discuss, we need to take a quick detour to explain some lingo, no? So to understand the difference between these two branches of statistics, you need to understand two important words. The words are population and sample. First up, no, population in statistics, the population is the entire group, let's say the entire UDM community, or let's say all all community within Quezon City, no, or Manila, no. So that you're interested in researching. Let's say, for example, if you were interested in researching different owners, no, then the population would be all, let's say, kung UDM, no, and if you are interested to do research in UDM, then the population will be the all students in the UDM. Actually, students, all population, including the staff, the admin, the professor, and so on and so forth. However, it's extremely unlikely that you're going to be able to interview or survey every single student or employee in UDM. So realistically, you like only get access a few hundreds or maybe a few thousand owners or a few thousand employees or persons using an online survey. And this smaller group of accessible people whose data you actually collect is called your sample. So let's say, for example, all CIT, no, IT in engineering, I think, CTE yata, no? But you just only focus with IT, no? So the entire engineering and IT department is a population. But since you just only provide survey to the IT students, that is sample, no? So descriptive statistics focus describing the sample, while inferential statistics aim to make prediction about the population based on the findings within the sample. In other words, we use one group of statistical method, descriptive statistics, no, to investigate the slice of cake, and another group of methods, inferential statistics, to draw conclusion about the entire cake, and there we go with the cake analogy again. Okay? Now, descriptive statistics serve as a simple but critically important role in your research, not to describe your data set, hence the name. In other words, they help you understand the details of your sample. Unlike inferential statistics, descriptive statistics don't aim to make inference or predictions about the entire population. They're purely interested in the details of your specific sample. So when you're writing up your analysis, descriptive statistics are the first set of stats you'll cover before moving on to the inferential statistics. But that said, depending on your research objectives and research question, they may be the only type of statistics you will use. So, what kind of statistics are usually covered in of course, in descriptive? Just mean, median, mode, standard deviation, skewness, of course, and so on, no? So, descriptive statistics, again, describe, show, and summarize the basic features of dataset found in a given study, presented in summary that describe the data sample and its measurement. So it helps analysts to understand the data better, because descriptive statistics represent the available data sample and do not include theories, inferences, probabilities, or conclusion. That's job of an inferential statistics. Okay, so in descriptive statistics, we have what we call distribution or frequency distribution. So we have, of course, measure of central tendency, no? We have, of course, the variability, also called dispersion, wherein this topic will be able to discuss by the next presenter next meeting or on Tuesday. We have variance, no? and what we call univariate descriptive statistics, because univariate descriptive statistic example only one variable at a time and do not compare variables. Rather, it allows the researcher to describe individual variables. As a result, this sort of statistic is also known as descriptive statistics. And the pattern identified in this sort of data may be explained using the measure of central tendency, data dispersion, tables of frequency distribution, pie graph, frequency polygon histogram, and bar graphs. Another, of course, is the bivariate descriptive statistics. No? When using bivariate descriptive statistics, two variables are concurrently analyzed to see whether they are correlated. Generally, no, by convention, the independent variable is represented by the columns in row represent the dependent variable. And there are numerous real-world applications for bivariate data. Example, when a natural occurrence will occur is quite valuable. No? Bivariate data analysis is a tool in the statistician toolbox. Sometimes something as simple as projecting one parameter against the other on the two-dimensional plane can better understand what the information is trying to convince you. Let's say, for example, the scatter plot below demonstrates the link between the period between eruptions and the Old Faithful and the eruptions duration. Okay, so descriptive statistics can be useful for two things. Again, providing basic information about variables in dataset, highlighting potential relationship between variables, and the graphical pictorial methods are measure of the three most common descriptive statistics that can be displayed graphically or pictorially. No? It is used to summarize the data, and these descriptive statistics only make a statement about the data set used to calculate them. They never go beyond your data. So we have scatter plots and of course some other applications. No? So I will continue to play a video presentation a while ago, no, to give you some additional inputs, no, for this topic. Okay.